thanks for joining. We've got a great turnout. And I think what's going to be a really, really interesting evening. Okay, so I'll do a quick introduction. We'll try to get to the most interesting part that you're all looking forward to as quickly as possible.
Sales.
Beer. First of all, did anybody hear if the Blue Jays won last night?
Something about that. Yeah.
Thank you, merci to CBC, to Francois, to Mathieu. Thank you for making this space available, for giving your time, and for sharing what you're going to share tonight. Really appreciate it. Thanks to our sponsors, Applied, TAG, and Grass Valley, helping make this possible. A few quick updates. So tonight, social meetup for anybody interested, anybody who would like to go for a drink after this. Grace O'Malley's 14 Duncan Street, which is just 2 blocks north of here. Okay. And our September meeting, which I think was great. We had Nils Borg, who's the EBU chair of HTML graphics, presenting. It was really engaging, lots of great questions. That is on our YouTube channel. So if you're interested, it's really worthwhile to check that out. That was also our first midday meeting. And so it was a bit of a test, and we ended up with 60 people joining. So it was a really good turnout on a Thursday midday. And we had our first social meetup in September. And again, excellent turnout and excellent feedback from those that were there. I thought it was a really fun event. So we're going to keep doing those and keep growing that. So please, we appreciate all our members. If you are interested in becoming a member, if you're interested in becoming a friend and getting on our email list, and we are working on, as I mentioned in September, working on our LinkedIn page, a new LinkedIn page for SMPTE Toronto. So that'll be coming soon as well. And at this point, I'm going to turn it over to Silvino for the next section. Okay, so enjoy.
Thank you.
Recording in progress.
Thank you, Ron. Well, good evening, everyone. So questions, they have the QA. Tony is going to help us to moderate the QA. So we have questions, people that are online, please send the questions. It'll be very interesting even today. So very interesting topic. Afterwards, YouTube, you can review the meeting you have today. Washrooms, so everybody here already know where is this, so doesn't need to go there. And there is a hands-on session afterwards for those that brought their laptops. So the power bars, they have power bars under the tables. Okay, so if you need to power your computer, it'll be a long session, a lot of power. The Wi-Fi, so who needs to download the GitHub material? Wi-Fi at CBCRC, don't need a password, just log there and the browser authenticate you. So that's for today. We start with recognitions. Last week, 2 weeks ago. Last week,
Yeah, last
we have the SMPTE in Pasadena. And SMPTE together with EBU and VSF, we won the Emmy for technology for the 2110 standards. So Felix Poulan, that most of you know, he's part of SMPTE, was part of the EBU, is still part of the EBU as well. So he was one of the person representing the SMPTE. So thank you for all the hard work. We also SMPTE won a second Emmy for the IMF standards, suite of standards. So on the technology as well for the ST20667 family. And our presenter today, Mr. Francois, became a felon, SMPTE felon. So congratulations. I copy your LinkedIn.
This is should have taken the one just
Okay, so today agenda, yeah, we have two parts. First part, Francois is going to give us the introduction to MXL project and the CBC E250 project. And on the second part, Mathieu is going to guide us through some hands-on on how the technology works. So thank you again for your time. Not going to take much time of you because these people has a large bill that you can read afterwards, right? So since they started, so the bills are becoming larger. We need some AI to shrink them for everyone. So thank you all of you for coming here today and enjoy the evening. And that's it, Francois.
Thank you. Thanks everyone for joining us tonight. It's a pleasure to receive you at CBC. If you have questions, please ask through the Q&A and I will try to answer them as they come in. I prefer in context that after when there's a totally different context. So today the presentation is going to be about what we call internally the E250 project. We are engineers. We're really bad at naming project. I know that. The EBU's DMF initiative, the MXL project, and all this is all linked together. I want to thank a lot of people that helped me with that presentation. So a lot of colleagues as well as Thomas Edwards from AWS. So a shout out to them for helping me. So before going into the core of the subject, I want to take a few minutes to explain where we start from. And it's always better to understand the current situation to project ourselves in the future. So we spoke a lot about that project, but I believe it is still a very worthwhile project. This is the new headquarters of the Radio-Canada French Services in Montreal. It went on air for the very first signal in 2019, already 5 years old, and we fully migrated to that building in 2022. It took 2 years to migrate one show after the other in the new building. And when we built that building, 2110 was new. We wanted to use it. We often ask ourselves, do we want to be the last SDI facility or the first 2110? It turns out that there's still 21 SDI facilities being built. But we ask ourselves, why should we go to IP? And one of the reasons was to reduce the number of wires, and it really worked out. The amount of wire in that building, there's hardly any wire, hardly any. There's probably only 100,000 wire, which is nothing compared to millions of wire. So there were a drastic reduction in wiring. We can support any production format on the same router, different frame rates, different resolution, interlace, progressive. We tried to kill interlace, but it didn't work. But still, we can support all of those formats. Vertical, square, name it, the network can carry it. We can pool production resources. So the router is practically unlimited. So having an unlimited router means everyone is sharing the same router. So devices becomes available to anyone without having tiny pool of devices. And we can leverage the IT industry innovation. When we started to reflect on IP, SDI was 12 gig and mainstream IP was 10 gig. So SDI was ahead of the mainstream IT at the time. And well, 5 years later, SDI still is 12 gig. And the backbone we're installing in this building right now, it's already outdated. And it is 400 gig everywhere. So it goes there's a much faster rate of innovation with IT, and we wanted to benefit from that. But was this good enough to justify all the pain of going through the transition to IP? Most of the people that worked on it didn't have any gray hair when they started. And by the time it ended up, we all had gray hairs. So is there a killer app with IP, something you want so bad that you're willing to go through all the sacrifice to make IP work? And yes, we always believed they were a killer app, and the killer app was to replace the hardware with software. That IP would be the gateway into the software world, a prerequisite. And that it didn't really worked out, at least not for this project, because it was a bit early for software. We had a product we bought, FPGA based, that we were told those are as flexible as real software. You can change the behavior of the FPGA for whatever. It didn't work like that. And some of the product we bought are CPU based, but at the time, having a pure software audio console, it was not there yet. At the time, having a very low latency, high quality multi-viewer, it was not there. But for production, we didn't add any software. We tried with a video server company. It turned out it was difficult, so we ended up with hardware. But for master control and presentation, we are pretty much all software. So our ITX is software, Tag Multiviewer is software, Numeris encoder, we work with ROS Video with software. So it worked out for playout to go software, but not for production.
Question, François.
Oh, yes.
For the new CBC building, is there any SDI layer for disaster recovery in case of a general failure of 2110?
The answer is no. No.
I was trying to type the answer, but I was not able to. So.
Yeah, no, the answer is no. There's everything is doubled up. But everything is built not like onions, but yeah, it's pretty much an onion. So at the core of the onion, and we like to name our network with colors. So at the core, it is the green network. And of course, there's two green network. I will never say there's two, but there's always two of everything. And the green network is what feeds the BDUs and the transmitter, and that's at the core, and you cannot access it from the outside. And that network is really, really small, so the odds that it's going to fail is quite small, but it may. That's why we have two of them. Then around that, we have a red and a blue master control and presentation network. And again, there's two of them. If those two fail at the same time, we can have another location that directly can connect to the green network for distribution. And then around that, there's another red and blue network for production. So it is built as layer inside the layer, two all the time. The red and the blue are not fully air-gapped because there's no such thing as an air-gapped network in modern world. So they are air-gapped-ish, but not really air-gapped. So, but no, there's no AES layer, no MEDSI layer, no SDI layer, no analog layer. If there's a major network issue, then we're off the air. It almost happened once in the early days because of a PTP issue. And the PTP distribution is the same for everyone because everyone has to be synchronized. And we had a failure of the GPS distribution. We lost GPS. Everything started to drift, but we were still on air. And when we realized it was drifting, it's because we were starting to log tick, audio tick on radio on air, but just one tick every minute or not. And then we figure out what happened. It was like 10 a.m. And then, oh, okay, this is what happened. Let's fix it. And we went off the air when we fixed it. So we should have lessons learned. If that happened, let it drift for the whole day. You may have a bit more tick by the end of the day, but do it at night. because we were off the air for what, 5-10-ish minutes, which is not. Yeah. So, but there were lessons learned at that time. We make our BTP distribution better, but no, there's no legacy backup. So as I said, there is two transitions. So we want to go from SDI to IP. And at the same time, we want to replace the traditional broadcast specific equipment with containerized software. And those software, they can work on-prem, in the cloud. It's your choice. I don't care. I want to go in software, and then where is that software running? It's a business decision. It's what you're comfortable with. So, but the thing is to move there. And the transition that's going to give the most benefit, we believe it's to move to software. But the prerequisite is to go to IP first, and then you can go to software. So with the new Maison, we were kind of almost there, but not quite. So now we have a second chance to make it right. I hate that slide was not built by me, because I would never have quoted myself in a slide, but I'll go. The problem is that we don't have a crystal ball. We don't know where this industry is going to be in 3 year, 4 year, 5 year. So it is difficult to plan for, okay, we will rebuild this facility, and where will CBC be in 7 years? And let's build for that. I have no clue. So the only way not to fail is to build for maximum flexibility. So to go from a place today where we have fixed purpose facilities to something that it's much more flexible, agile, scalable, that can be dynamically reconfigured for multiple different types of production. I often like to say that on a daily basis, we don't do a lot of sports, but every 2 years we do the Olympics. So then we have to build a lot of facilities just for that. What if it would be all software, not a click of a button, but dynamically reconfigurable? What if we could leverage public cloud? There's a lot of benefit we see, but those all requires to go software first. Another driver why we want to go with in software is that we just went through a project we call the local expansion project to add more journalists in the regions. We have launched, and we will launch more fast channel. We need to produce content for those fast channel. We have journalists, we have fast channel, but in between, we don't have more control room and more production resources to create that content. So we want to build an infrastructure that can be leveraged. Again, there's another fast channel. Here's your virtual control room. Use it, and when it's gone, it's gone. You tear it down, and the day after you can recreate another one. And the goal is to do more original production for much less cost per production, not necessarily less total cost. That's remain to be seen if overall it's going to cost less, but the cost per production is, we believe with software, it's going to be lower. So the new Maison project in Montreal, the goal, and we succeed, was to learn how to build massive media over IP facilities. The goal with the E250 project here is to learn how to do massive software-based infrastructure. If you may ask why E250, 250 is 250 Front Street. That's the address of the building. And E stands for evolution, and there's a bunch of word that start with E, but it's to evolve our infrastructure in this building. So part of the project, we came up, that's an horrible name again, with the Universal Production Platform. The Universal Production Platform is whenever we don't know what to do, how to design stuff, We go back to key principle and we ask ourselves, okay, given those key principle, what should I do? And it should help you to answer that question. So it is based on 4 key principle that combine establish IP, because I believe by now IP is mature and it is established, with emerging software-based processing technologies to deliver flexible, scalable, adaptable production infrastructure. So principle number 1, all the principles seem simple, but the word were kind of carefully chosen, and there's a reason why there's those principles. So the first one is there's a clear separation between a studio, a control room, and shared production resource. We don't call it control room because maybe the operator will not be in a control room. He might be on his laptop in a meeting room or whatever. So we call them operator's position, but to make it simple, if it processes a signal, it goes in the data center. If it is used to control equipment, it goes in the operator position. And if it's used to create, capture sound images, it goes in a studio. So this one is, it's quite simple. There's another broadcaster that had exactly the same principle in a very large project recently. That's an old logo. It's Eurosport. Eurosport got acquired by Warner Brother Discovery, so I should have removed the logo, but they did exactly that. What's interesting in their project is that between the control room and the data center, there's hundreds to thousands of kilometers. They're not even in the same building. Principle number 2 is that the only thing you're allowed to use to interconnect those rooms is IP. And when we say IP, it's IP. IP, it's layer 3 of the OZ stack. So everything that, yeah, it looks like an RG45, but it's not IP, it's not allowed. And that makes it way easier to have one network where everything runs on the same network, and you can interconnect those facilities. And if we pick the proper codec, it can connect to the cloud, it can connect to people at home. So IP brings that flexibility. Again, we're not the only, well, we did that in Montreal with the new Maison, but NEP in Australia did a massive project where they did exactly the same. They had the same principle. IP is used to interconnect everyone together. Principle number 3, we will always favor software when it's possible. So if we have 2 options, I want to buy a scope, there's a hardware scope and a software scope. If they're almost equal in functionality, go with the software. So we want to always favor the software one. Why? There's a bunch of reasons. It's going to run on shared hardware that can be reused to do other things when you don't need a scope. Software can be extended to the public cloud when needed. And most of the modern production technology works perfectly fine in the cloud, whether you're an AWS or Microsoft, a GCP, Google cloud, it works. You can have that choice to go wherever you want. You see that shared memory there. More on this later. That's important also. And again, that's not new. OBS did that for the last Paris Olympic Games for judo, wrestling, tennis side court, and shooting. And all the in-city Milano venue next winter, it's going to be all software. So their production switcher, it's going to be software. Their scope is going to be software. The audio console are going to be software. So if they can do the arena sports in Milano with software, we can do the newscast with software. Principle number 4, there is nothing that's going to be permanently assigned. So today there's a lot of situation where we have one show, one person, one control room, his audio recorder or his video, whatever, and that's a bundle, and that bundle is tightly coupled. So we want to make everything pooled, share. You want an audio console, you take the next one available from the pool, and you're done with it, you released it. But that's going to require a very good resource and content and infrastructure management tool. I don't know if that exists, but I guess so. So it's going to take some tools to manage that. This slide, one day I'm going to remove it. So that's why there's that big. So we are perfectly aware that sometimes it's not possible to do something in software today, and you still need some traditional hardware-based equipment, but this is less and less and less and less true as we move forward. So a good example is cameras. Yes, they're required to capture light, but Red, they have a virtual CCU that can be used with their cinema camera to shade a cinema camera fully in software that runs. It was demonstrated, je vois ta face, in the NVIDIA booth, in their HoloScan for media demonstration. They had a virtual CCU fully containerized in software that could be used to shade a camera in software. So yes, the light sensor doesn't exist yet, but there's other part of a camera that do exist. So that's the Fisher-Price version of the model. During the whole presentation, we will always come back to that slide, but we have a little bit more detailed version of it, but it is the same. It's the studio space, the control room, the data center, and we will go back very often to that platform vision we have at CBC. So using software for media production, are we there yet? Not always. So there's a few problems today, very important, that needs to be solved. The first one is that using traditional technology, you cannot make one application bigger than what fits on a single server. So if your goal tomorrow morning is to take the biggest Grass Valley production switcher and run that in software, it doesn't work because it's too big. It doesn't fit on a single server. But if you want to take something smaller like a Kairos, it would fit on a server. So the very big one still don't fit on a single server. There's also vendor lock-in. So there's a lot of solutions on the market to do video in software, but once you go into that specific vendor ecosystem, it's very hard to add partner to that ecosystem so that it looks consistent. So there is a risk of vendor lock-in. There is high latency. That's something we haven't spoke about, but SDI was much lower latency than 2110. An SDI production chain, as you cascade equipment, you add lines of latency. With 2110, all of a sudden you add frames of latency. And we're already in the 500 to 1,000 times worse in terms of latency. And as you go to software, you add those frame plus buffer plus another buffer. It really grows the latency, so that's an issue. Very often, the software-based production solution we see at an AB or IBC show floor or in the cloud, all of them in the cloud, they will use NDI or SRT to connect all the components together. And that means it's even more latency than 2110, and it also reduces the picture quality of the demonstration. A very good friend of mine told me that all the demonstration in the public cloud of software production you see at NAB, in order for them to look good, they will run NDI at 4, 5, 6, 7 times the native bitrate of NDI. So that they get rid of that compression artifact by doing that. So it also, yeah. And the other issue with software solution today is that either they are very specialized, like Spalk. Spalk is quite interesting. It's a commentary and description service in the cloud for sports. It's software, it's modern, but it do just one thing. And then to integrate that with other, you need NDI or SRT. Or the other thing that we see a lot is a jack of all trade, but master of none. So that's a Swiss Army knife. Or I prefer the spoon fork. If you try to eat soup with a spoon fork, it's awful. If you try to eat spaghetti, it's awful, but yeah, it does a little bit of both. So a lot of the current solution for using software, they're like that. The other issue we have is that very often you will see a use case, public use case like this one. It came from Grass Valley. I have nothing against Grass Valley. I'm just using it as an example. And it's always a sporting event brought to the cloud with software. They create a regional variation for it, and then you distribute it. So those workflow, they go from one side of the drawing to the other side, but there's no set monitors. There's no interaction whatsoever from the control room with the players playing tennis on the field. So those workflow are pretty much forgiving with latency. But in real life, there's a lot of workflows where it's not latency sensitive. Radio-Canada, they have that show, it's called Tout le monde en parle. You see that shot very often. You have one output of the production switcher that feeds a set monitor, then you have another camera that captures it. And in SDI, you can do that way below a frame. In 2110, that takes 3 frames, and in software, we were not able to make it faster than 6 frames. So as he moves, now you start to see some delay. That's a corner case on TV, but for Pro AV, image magnification, they do that all the time, where they take the actual action, put it on the jumbo screen, and you cannot have a second of latency between the two. So that in software right now, it's very difficult to do. Audio, it's even worse because they don't count the frames, latency in frames. A few milliseconds, it's already too much. So some may argue, is it 5 milliseconds, 4 milliseconds, 6, but it's somewhere in that range where it starts to create problem. So this today in software, it's difficult, but some vendors are starting to use new mechanisms that we will talk later in software to really make the latency lower. And for now, I fully recognize that there is some local hardware that's going to be required for some audio workflows because of that latency issue. So far, so good. Yeah, it's not too boring. No? Okay. And do we have questions online, or we're good online? Okay. So part two is something called the DMF. DMF stands for Dynamic Media Facility, which is an initiative from the European Broadcasting Union. It's a group of a work group. They did a couple of things recently, but one that is very interesting is that they released a white paper around NAB 2023 that starts to talk about what is required to build dynamic media facility in software with media functions that are interoperable between the vendor so that we avoid lock-in. And that is, it's a layered model built using standard IT technologies. A year and a half after IBC of last year, 2024, they released another white paper with the collaboration of many of the vendor. It explains what is a workload lifecycle or a workflow, and we'll talk about it. Again, it's based on an IT stack, but with more detail to try to build a common understanding in the industry of how we can build such a thing. There were some gaps identified also on how to make things interoperable between vendors. And that exercise is chaired by Peter Brightwell from the BBC R&D department and Willem Vermos. Willem is no longer with VRT. He's with EBU now, but VRT was involved. And so in that document, basically there's, we want to build a common language, and a workload is a production that needs to be planned, then it needs to be built, provisioned, configured, then you can execute your production, then it can be reviewed. So if something failed or you want to improve something for the next time, you can review it, and then you destroy your workload and you restart it after. I don't want to go into all of the detail because we can do just on that topic close to 1 hour. And there's also in the white paper the notion of what would be a proper layer model inspired by the IT industry to build dynamic media facility. The first thing is that there's the layer from the bottom, the first three, the EBU, and CBC was part of the exercise. We believe that by now it is generic enough that it can come from the IT industry. And there is Devon Croft at the last executive summit in, well, in fact, it's not true. They've said the same at NAB. Their projection is that today, a manufacturer that invests $1 below the blue line, they called it the blue line, will never see a profit on that investment. That it goes so fast from the IT side that get used to it. This is no longer from the broadcast industry. It comes from the IT industry, and it is what it is. And you as a manufacturer should focus on what makes you special, what makes you desirable by clients like us, and focus on the top of it. And don't try to build your own network adapter card anymore. Those days are gone. So the first three layers, they come from the IT industry, the top three from the broadcast industry. Infrastructure, it's server, it's storage, it's network adapter, it is the PTP time reference, it is stuff that you can touch, really, really tangible. The host platform is the operating system that you can assemble in clusters with hypervisors or container. Well, there is a container platform that goes on top of it. Again, the container platform, it's mature from the IT industry. However, some vendors are 100% into Kubernetes. They really like it. And other vendors feel it's way too complicated for their need. And they're perfectly fine with Docker by itself, which is okay with us. We don't have hard feeling with that. But the key thing is that in the model, it's container and container. Don't try to invent your own container technology. Pick one from the IT industry. And then there's the media exchange layer that we will talk later today, which is a way to exchange in the EBU white paper. In fact, it comes from the GT&M white paper that was published way before. The GT&M white paper, they have the notion of grain. So a grain of data, it can be a few samples of audio or a video frame. And the media exchange layer is used to exchange grains of data between media function, whether they are or not on the same computer. So that's the media exchange layer. The media function, it's everything you can think of that you need to do to build a facility. Video conversion, audio up mix, down mix, whatever, multi-viewer, graphic system. This is stuff we all know about. And then the application and the UI, it's what the user sees to interact and control those media functions. So something you will see a lot We're in Toronto. Evertz is a local company here. So if you take their Bravo Studio solution, they have media function, but the application and UI, they build their own UI with Vue, but they also partner with Skyhorn that does the panel to interact with those media functions. So it fits that model that the company doing the control panel may or not be the same company as the one that did the media function. It's another layer on top of it, and that's perfectly fine. What we really hope is that the media function will provide very good API that will allow us to build modern application or user interface. And we wish to use as much as possible web technologies to build those interface. And honestly, we saw some really good stuff using web technologies for UI from the market. Then there's vertical columns or pillar. So there's the provisioning that is required to create and destroy the resource at each layer. It is also required to configure to ensure that they are resilient and that we can build those facilities using the infrastructure as code principle. Everything needs to be controlled and monitored, and it needs to be secure. And security from day one should be part of the discussion. With 2110, the security was put aside, and we said, oh, we operate in an air-gap network, so we don't need to worry about security. In that case, we want to use principles like zero trust the term, I believe, was invented by Google. We want to be able to leverage that. So if you feel sleepy but not quite enough and you want to make sure you will sleep very well tonight, you can read the white paper. It's on the EBU website. It's not that long, honestly. It's a 15-20 minute read, and it's quite that's the basis of what we're doing with our project right now. So we have a real project. The reference architecture is very forward-looking, but we want to build a facility like now. We want to use part of that for the Olympic game this winter and shortly after or before for some regional newscasts. Is it after or before? Before. Okay, yeah, before. Okay. Approved. So then it needs to, we have to implement it in the real world. So how we start a project at CBC, we do an RFP. We like to do RFP. And but not this time. This time we change a little bit the typical way of doing the RFP. So the first step, instead of writing the RFP, we told the industry, we've been doing that for more than a year. We want to go in software. We want to go in software. We want to go in software. So that when the RFP comes, the whole industry knows about we want to go in software and nobody is caught off guard. So that was the first step. We did not an RFP, but what we call an RFSA process, which is a little bit more flexible. And the RFSA process is to procure media applications. So we want to procure virtual audio mixer, no kids in the room, that's a tape, it's to record video. There's no virtual camera, but you get the picture. And at the same time, we want those to connect together. They need a platform to live on, and that notion of a platform doesn't exist. So we tried and we organized several events, including one in this building just before last NAB, where we took businessmen that wants to sell stuff with customer like us that wants to buy stuff, and can you get together and fix that platform problem so the media app from vendor A can talk with the media app from vendor B. And if it's done properly, you see my credit card and you see the people should make money out of it, because at the end of the day, there needs to be a business ecosystem for that to work. So but that part below, the whole thing of standardizing those media function, at least the way they interact together, is not part of the RFP because it didn't exist at the time. And eventually it may or may not converge. And when it converges, then maybe we'll do a proper RFP, but that's down the road. We're not there yet. This is very similar to application on your smartphone. And in the early days of smartphone, Microsoft tried to have a Windows Phone OS. BlackBerry, they did succeeded, but it didn't work forever. Palm, Apple, Android, there were like 5 platforms out there. And over time, only 2 did survive. And there's a lessons there for us, because one of the results of our RFP process is that right now there's tons of vendors that propose a platform to host media function application, but we don't believe there's enough marketplace for all of them to succeed. Or if they do succeed, they will not succeed at the same level. So for us, we feel pretty much the same as in 2014, when Sony had the NMI standard fighting against the, well, that's funny because in the one that at the end did won was none of them. It was TR03 that became 2110. So we feel in the same situation, and we believe the industry needs to, that's why here we say it needs to converge. We need to reduce the number of options so that hopefully there would be less option for us customer. The RFP we wrote, we asked for 30 different media function: audio upmix, audio console, multi-viewer, clip recorder, clip player, whatsoever. We got 12 vendors that qualified to the minimum requirement, and combined they propose 170 media function. The funny thing is that 3 of the vendors proposed their own platform. You can guess who they are. Of course, GV did propose AMP, and of course, Lavo did propose Home, and you know the guy. But the funny thing is that none of the other vendor that didn't have a platform, they didn't even want to commit to support the other guy's platform. So that for us was, it was a moment de vérité,
Eye-opener.
an eye-opener that I don't see the day where you would have a dream catcher on AMP. I don't see the day where there would be those kind of interrupt in software. It's definitely not for tomorrow. So we need to do something and help the industry to address that. And so that's why we believe there's a lot of people, they wrote app having no clue on which platform they will run. So there's a desire for a direction. So knowing that, we ask ourselves, what is the minimum viable solution so that I can have my vendor A that will play nicely with vendor B? And honestly, if they each have their own server, it's not ideal, but I can live with that. If one runs on Linux and the other one runs on Windows, I don't like it, but still maybe I can live with that. If one is on Kubernetes and one on Docker, okay, that's fine. If they cannot even talk to each other without using NDI and SRT and compression and those high latency, low quality codec, then that I cannot live with. So we decided that this was the first layer to try to align and between the industry. So we went back to the EBU. We worked with them to try to build something to fix that problem. So there's a couple of, how much time do I have? I need to go really quick. So there's another hour of presentation, how we got the industry to converge. They did finally converge, at least a part of the industry, to something we call the MXL, and I will explain what the MXL is. So let's say you want to do a very small software, a very small production in software, 2 cameras, couple of mic, set monitor, and some remote feed through bonded cellular or SRT. And you need a couple of multi-viewer, a couple of screens, production switcher, audio console. So you get the idea. And let's say you want to mix vendor A, B, and C and D to work together. So the traditional way to do that is to traditional in software is okay. You would have one software that runs on one server. It goes 2110 to the network or NDI or SRT, then back to the second server, back to the third server. This is exactly in Montreal how we build our master control and presentation. We have ITX that goes to the network 2110 to the tag multi-viewer, and then back to the network 2110 to the screen, and you get the idea. The other way you could do that is you run all those software components on the same server. However, you don't go back to the network to exchange the data between the media function. You use the local interface, the local loopback interface to connect them together. So you reduce the network bandwidth because that IP network there, it's the NIC, it's not really the switches. Yeah, okay, it's better, but you still add latency, it is still problematic. So the other way to do it is, okay, what if we could agree all the vendor on the same platform to share the memory between the application? And then you could be asynchronous and be much faster and lower latency and less waste of resources than doing back to the network and then back in. So we'll skip that. So this is basically the MXL SDK. Is exactly that. So it is an SDK from our industry, not the IT industry, proposed to the market so that we can have vendor A, B, and C. I don't know, graphics renderer with a video mixer that would share through memory their frame by having a bunch of ring buffer in memory so that one media vendor can write frames to memory or audio sample. The other vendor can read directly from it. And sometimes they may be on the same server. Sometimes they will be on a different server. And whenever they are on a different server, they can use modern IT technology to read the memory. So that's server 2 can read the video frames written in memory by application on server 1. So this is, in a nutshell, what the MXL SDK is all about. So I will skip that. It's an SDK. An SDK, it's a software development kit that can provide a bunch of functionality. I would skip that because I want you to try the SDK later today. It is open source. It's already available on GitHub. The SDK, the MXL SDK, it's a project managed by the Linux Foundation. Why? Because our industry is it's amazingly fast when the engineer from competitors went in the same room to fix the problem. They fixed it like that. Then came their legal department, and how can we make that work together? And the Linux Foundation, there's, well, yes, Linus Torvalds worked there. There's a lot of good engineers that work there, but they have more lawyer than engineer that speaks the same language as the lawyer from the vendor we work with, and that they were able to resolve those intellectual property stuff, and they were really great in working with us in that initiative. Why an SDK? Because we believe it's going to reduce the time to market as opposed to the traditional SMPTE standardization mechanism. I know it's a SMPTE event. SMPTE does great thing, but speed is not always one of them. Having an SDK, it's going to reduce the barrier of entry for new people to adapt the technology and go there. And it's going to make sure that it's going to be interoperable, because Traditional mechanism, you have engineers that write a spec that is passed to developer that reads the spec, will develop a product out of it. Interpretation of one developer is not the same as interpretation from another developer. Then you may have weeks, months, years of interrupt testing, and ultimately it's going to work, but it's going to take time. But if everyone is using the same SDK, it's going to be much faster. I will skip those. Skip that, skip that, skip that, skip that, all of that, because Mathieu will think I'm just pushing back Mathieu stuff. Yes.
I have a question for you.
Yes.
If you wish comes through and everything comes software.
Yeah.
And we know softwares are getting more complex. So is CBC building your own AI to supervise all that?
No, we're not building AI. We may use AI, but
You're building a genius team that understand all the software to make sure everything works and doesn't cascade failures.
so we will have a good enough team of a few genius. Well, the first thing is that things are getting so much complex that nobody understands it from A to Z. So you need a team of people willing to collaborate together on those projects. So that's the first thing. The second thing is that there's a lot of problem we're trying to solve that other people, other industry did solve. So we don't want to solve everything by ourselves. When there's something that does exist from the IT industry, we use it. And that comes with a lot of good people able to support us. So we're not on our own. Part of our internal experimentation, we are strong believer in HTML5 graphics. And we had a VizRT operator that we asked him, can you port your template that you build in Viz into HTML5? And the guy never wrote a line of code. And he sat with Gemini a couple of days, not hours, but he built, it's amazing. Now you can ask Gemini, do me a template that do blah, 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 and he has it like that. Is it the most optimal code? Maybe not. Does it work with our render with M? Yeah, it works out of the box. So it's, so I believe AI will play a role, but it's not going to be magically driven by AI. You still need people that knows how to work with that.
I have a question for you.
Yeah.
Do you think vendors will rebuild their current systems to support MXL or just adapt it? For example, GVM uses their own kind of MXL called frame catch.
Yeah.
I don't think that GV will rebuild this.
Okay, so there's a couple of answers, and I will be François Legrand. Again, I hate to say my name, but I'm starting to be recognized for that. I don't want them to lift and shift what they have today into that world. So if they just want to stitch MXL on it, stay in your old legacy world. Don't come to the MXL world, because to work in that world, we haven't spoke about it, but the whole thing is asynchronous. And most of the current stuff that people have works with synchronous data. So if they're not willing to rebuild it the right way, I don't care. A lot of the current application are massive monolithic application. If you don't want to port it in smaller, tinier, leaner container, don't come to my world. I don't care. But most of the people on that slide, and that represent a tiny portion of the industry, but it's starting to build some momentum. They were willing to rebuild their thing to support that. So I believe there is hope there. To speak about Grass Valley, it's public because it was said at the GV forum before the IBC. The answer is yes, GV will rewrite the frame cache to be MXL native. It's not my word. Jan Fletcher said it publicly, so they will do it. The other companies may or may not do the same, but more than one company here already said it publicly that they will rewrite their own thing. If they already have something modern in a container, they don't want to rewrite the whole thing, that's fine. You can use MXL as an IO mechanism. We have like 10 slides on that, but I didn't have the time to cover half my slides, so I skipped them. But yes, there is company that will do that, and it is better than nothing. The MXL project, it really comes from user requirement. So it is people that has requirement that they fight between them to establish priorities. And then once the priorities are established, there is a technical steering committee that said, okay, now that we have that, how will we implement that? And there's a few problems in that slide. The first one is that if you look by region, there's probably more European companies than North American companies. So we need a bit more of the everts or the US companies to be on that slide. That would help to balance things. The other thing is that there's way more vendor than end user. So we need end user to join the project also. And but you can see that there's a significant amount of traction already. And a lot of those companies, they have already started either to implement or they showed it at IBC or NAB. There's also a couple of cool one like that logo here. Who knows what it is? Yeah, you know, but come on, Anthony, do you know who that logo is?
OBS.
Yeah, thank you, Anthony. So the OBS.
Not the OBS that makes the converter thing, OBS, the open broadcast software that's installed on
Yeah, exactly.
billions of computers.
Exactly. So AWS already did a plugin for OBS to support MXL.
Yeah.
It's not perfect, doesn't do audio yet, which is a big problem, but that's going to be fixed. And there's so there is like free stuff, traditional vendor, newcomer, some from the IT industry, like NVIDIA and Intel. But other than that, it is mostly our industry behind that. Yes.
If you consider using the OBS as an application or a starting point, considering that it's such an open source initiative, does it have the building blocks that you're looking for built into it?
Not seriously. We haven't seriously considered it, right? Right now, we work mostly with traditional people. Yeah.
May I ask a specific question about the ring buffers?
Yeah.
Obviously, each ring buffer has to be addressable.
Mathieu will show it to you.
You'll get into that?
Yeah, those ring buffer for those with the laptop, they will run on your computer.
Okay. And then within that ring buffer, understood, you'll get into it, but each point in the ring buffer will need to be addressable as well.
Yes.
Yeah.
And then the closer you're addressing your read compared to the right will reduce the latency.
Yes.
Yes. So part of the IBC, there were a couple of public demonstration of those, some big, some small. Sometimes, yes, you can see GV was in more than one of the demo, but it was not just GV. Sony was there, Matrox, us, Zoom. The Zoom one is a really cool one. That's their demonstration. It is Zoom ISO as a container running into a GVM host. And they take a conference call, just like the one we're doing right now on Zoom, and turn that into ISO cam for each one of the participants. It also sends back the return feed, so the program output feeds back. It feeds back mix minus for communication, and Zoom is one of the very few companies that full integrated audio also. So it is audio, video, both ways. With Zoom, that's a very cool demonstration. We really liked it.
Using MXL.
Using MXL, yeah, that's all MXL between AMP and Zoom. That's how it worked. The cool thing is that it's not Zoom that have implemented anything from AMP. It's AMP that have implemented the Zoom API. So that for Zoom, their container, they gave to GV to run on their cluster. They could tomorrow take the same and run it with the Neton or run it with the Simply Live in MXL, and it would be the exact same container for them to work with all of those platforms. The only one that does exist is the AMP demonstration. Those here, it's artist rendition of where they could put their technology, but it is interesting. Another demonstration, it's much more complex. It was in the AWS booth to prove that the exact same SDK can run in the public cloud. This one was another one, multi-vendor at.
But I believe there was some very, in this slide, one of the very nice thing is that on this same host, the same EC2 instances, you have TVU, Riddle, Matrox, and M.
Yeah.
The same one. They're not running on their own host, they're running in the same host using the SDK to exchange. That's quite something.
Yeah. TVU, they release at IBC Media Mesh, and in their case, internally, they have their own memory sharing mechanism. They use a lot of compression because their goal is to have some people in the cloud, some people on-prem, scattered a little bit everywhere. So they do need compression for those links. But when it's local to the same network, they use the MXL connector to connect to their mesh, which is an interesting use case. Sony, they have the M2XL production switcher. So this is a production switcher, but it's fully in software. It runs on a single server. And they look at this test pattern. If you're good, it's going to run on your laptop later tonight. And this one is interesting. That's the latency graph of the writer to reader delta. And for the 2110 input, it was a 50 frames per second progressive demonstration. So it means 20 milliseconds steady. But the everything that was MXL is a straight 0. So their read and write pointer, it was not 0. It's probably, I don't know, 1 millisecond, 500 micro, something like that. But at that scale, it is being shown as a straight 0. So this is quite interesting. We did also a demonstration CBC at the EBU, same or similar demonstration to what we will do here tonight. And yeah, so that's it for my part. Yes.
Could you speak to in your infrastructure layer?
Yeah.
How much GPU would be required compared to CPU goals and certain functions? What would require GPU?
The long answer is we have no clue, but I'm fine with that answer. So the very first server we built to try that, they were using the previous generation from NVIDIA, so not the Blackwell, but the other Lovelace. And we have L40S, and those are way too much powerful. All of the vendors we've tested with them will run out of CPU before running out of GPU. So the newest instance, we use the L4, which is 1/4 of an L40. It's not 1/10, it's 1/4 of it. And it's still not clear to me if we stroke the right balance of CPU to GPU. And we're really excited by the new Blackwell, because the new Blackwell from NVIDIA, they have a technology called MIG, and MIG allow you to slice a GPU, a big GPU, into a bunch of smaller GPU, so that each one of the container can use their own slice of a GPU. And you will tell me, oh, slicing a GPU, you can do that. In 2010, you could do that. Yes, but those newer GPU, it's not a time slice of the GPU. It is a CUDA core slice of the GPU and a memory slice. So you get those CUDA core all the time just for you, as opposed to 1/10 of a second, you have access to the GPU and then you need to. So it is much more efficient for video processing. So but that's brand new with Blackwell. So we don't know exactly how much CPU versus GPU. Yeah.
Thanks.
I'll try to not kick this off again. Yeah, as I was saying, you need admin rights on your PC. If you already did the preparation step, we can jump into the exercise directly. But if I just quickly go check one of this on Windows, basically there's a few prerequisites. You need to install WSL because the SDK is Linux based. It doesn't work natively on Windows. And WSL is just a virtualization layer to allow you to have a Linux machine running on your PC. We need a couple of tools, basically Docker. And after installing Docker, we also need to, specifically for WSL machine, we need to map a drive in memory. Because normally on a Linux machine, there's a bunch of folder like /dev, /temp, I don't recall others, but that are temporary file system that are already mapped to memory. So if you write in those folder, you're not writing on disk, you're writing in your memory, the memory of your computer. But under WSL, all of these are by default mapped to the hard disk, and we want to correct that. So at a quick glance, though, does people are ready to start? Have some of you done the preparation step, or we should allow for some time? The link is in the chat.
It's in the chat.
Google,
In the comment.
Excel,
It's on the SMPTE meeting as well.
The preparation takes too long, it's better go to the demo.
Yeah, I'll go. So those who have done the preparation, you can follow my steps, but if you don't, then you will be able to do it on your own after seeing the presentation, basically. So,
And it's gonna be recorded, so you can do it on YouTube.
so if I go back to the README, after the preparation step, there's three exercises that walk you through what MXL is, and we'll start with the first one.
Let's say you do it at home. Would you recommend Alma, Ubuntu, or?
I'm using Ubuntu. I prefer Ubuntu commands. We had a bit of issue with Alma at the beginning, but we've corrected those issues. Honestly, it should work on any Linux distribution. If you have one that you know best, just use that one. There should not be any difference. It's just that if you're not using the exact same distribution or the same base, you might have some command that will differ from the ones that are in the repo. But and with WSL, it's really quick because you can pick any of those distributions and install them. You can even try many. It's not that complicated. So in this first example, we will kind of build a very small system, a very small dynamic media facility, which consists of two apps, two Docker container running a GStreamer application that just writes a color bar into memory, and another Docker container that just consumes it, not even real time, because we're just using it to go see what's happening into the domain of the MXL domain, basically. So if we want to start, you just open a terminal in your Linux and you copy this first command. I'm going to open a terminal in Mac OS, which will clone the repo locally. It will take a bit of time because there's some stuff to download. And once it's done, we can directly go into the exercise folder. And look at the structure. So basically we have this, I'm just gonna try to make this scene. We have this setup where we will spin two containers. we do have a Docker compose file already built into the folder. And the first thing that we will do is we will look at this Docker compose file to see what we are doing with Docker exactly. So let's just go. I'm already in that folder. I'm just gonna do the next command, which is a Linux command to look at a file. And if we just quickly check this, there's two images that are hosted in this GitHub repo. It's going to be downloaded from the repo itself. And there's a writer and there's a reader. And the only commands that we give, the additional command that we give our system is to bind the volume where you did build in the preparation step, you built either a volume on your Mac or a volume in your Linux machine that is mounted into memory. So we bind this to the container so that we can write and read media information into this, what we call an MXL domain, which is basically just a file structure. It's just that this file structure is running on RAM. And there's a reminder here that if you did not just do the preparation step like I did in my case, on Mac, I need to start my RAM disk. So I'm going to copy this command, paste this here. It will start a RAM disk that we will see on the desktop just here. And if I go there, this is right now empty. But it's basically a RAM disk that have 512 megabytes of disk space. And let's just start these two images and we'll see what happens. So with the next command, it will start the two Docker image. Oh yeah, on Mac, I also need to start Docker desktop. On WSL, if you did the preparation, you don't have to start the Docker desktop because Docker can be installed directly in Linux, but on macOS, it needs Docker desktop to run. So now I will be able to start the two containers. In my case, I apparently did this already on my PC. It didn't download the image from the repo. I already had them locally, but they are started. And the next command is just to verify right now if those two containers are running. So I'm going to paste this. Those familiar with Docker will look that I'm using container ls instead of Docker ps. PS is going to be a deprecated command. So that's why we are using the new form, which is a bit more verbose as to what it does. Right now, I see that my two containers are running. There don't seem to have any issue with them. And we will have a look at the first command is docker execs from the container, from the reader container. We'll just look at the /domain. Why the /domain? If I look at how this is mapped, we have mapped the volume /mxl domain 1, which is our local disk here. If I'm checking there, domain 1, that's my MXL domain where my flow are in memory. But it is mapped inside the container as /domain. So this is why this command is just looking at what do I have, what's the file structure on of that folder as seen as my container. And good thing, it does match. It's only one folder and it does match what I have inside this domain folder, which is a big unique ID that finished by MXL flow. So that's basically the structure inside the buffers themselves. So each in the domain, every flow will have a unique ID. And inside the folder, you'll have all the structure. You'll have a .json that defines the flow as per the NMOS flow definition. You'll have some grains that represent media unit, either a frame of video or a portion, a certain amount of time of audio that will live inside it. And you'll also have some pointers to tell you on which grain you are right now. So let's go back to this thing. My container sees the same thing as my PC. We saw that there's a flow that is created. The next command is just a local variable to make so that it is a bit easier to use the flow ID, the unique ID. I'm just storing that unique ID of this first flow into a local variable, flow ID underscore one, flow one underscore ID that we'll be able to use later. And let's go check what we have inside this folder. Again, as seen per the reader container. So it's another Docker exec command. I'm still doing just an ls, which is listing files in the slash domain, but now I'm looking at the flow ID one that I've just stored. And inside that, I have data, and more specifically, grains. And on this repo at the end, we do have some documentation about the file structure of the ring buffers, where you have your domain, which is your root directory for all your buffers. You have a flow ID.mxl flow that contains a flow. Inside that, you have data, which is the flow header containing metadata for that ring buffer. You have a .json file, which, as was pointing by Jonathan earlier on, if you're not familiar with Linux, dot something file in Linux is an hidden file. So if you just do ls, you won't find it. You need to do ls-la or something like that. But it is the definition of the flow itself, the NMOS ISO4 definition. This will change relatively soon. Some of the developers have complained that this is an hidden file for absolutely no reason. There's no reason why we would need to hide this information, and they will make it that it will have a name and that it will be seen when you do a regular command. You have a .access file that is just used. Yes?
We have a question. How many grains a flow can have? And how much in the past I can read from the flow?
It's all configurable. So we'll see in this specific example how many grains we do have. It's not much, but it is configurable by time. So you can configure 100 milliseconds of time. It will, if you're in 30p, you'll store 1080p, 60, whatever, you'll store a certain amount of grain. If you're in 25, you'll store less grain because there's less frame per second. But it is definable for the domain, for the complete domain. It's not configurable by flow, but by domain. Thank you. The .access file is it's just a file that is used to see if a flow is used somewhere. It's to do housekeeping. And in the folder grain, we do have grain, and we'll see that we have individual grain by index. If we go back to the command, so we were checking this. Now we can confirm that it is the same on the host. So this is basically just looking at domain one and domain flow. So in domain one, we have one repository, one folder, which is the flow. And inside it, we have a data folder and a grain folder. But that seems as per the host. And this is one that start to get interesting. The next command, we still execute the command from the reader media container, but it is this command, mxl-info, which is one of the built-in tools in the SDK that gives you information either about a domain or about flows. And we'll look at what we get, what information can we get on this flow, on this specific flow. So if I execute that, I'll have the version of the app, the structure size. What's interesting here is the grain rate. That's the frame rate, basically. In video right now, we are writing 1 grain per frame. There are options to write slice of frame if we want to write smaller grain. But right now, the demo apps are writing 1 grain per frame. The question about how many grains do we have and how much I can go back in the future, in this specific case, only 2. I have 2 frames. Yes. Grain, it's nothing to do with programmation. It's from the GTNM ISO 4 definition model. It's a unit of media, and you define it as what you want. In our case, in this video example, it is 1 frame. That's the application is writing a grain of media is 1 frame of video. But a grain of media could be 10 lines, 15 lines, whatever you want. In audio, it could be represented as a sample or time period, how much millisecond of audio you want to have in your grain.
Yeah. This was, it didn't come from the DMF initiative or DMXL, but the GTNM reference architecture that was written by British guys a while ago, they already had built that vocabulary. So we reused it, and the problem with writing standard is that they wanted a word that nobody had an idea what it meant. So nobody comes with a preconceived idea of what it is. So they use that word, and the grain is a unit of media. And then how much media is there in that unit? It's up to you. Because if you want to write a very, very, very low latency and you need 1 line of video as a unit of data, make it 1 line. That's fine. But if you want it more efficient and you're okay with frames, let's 1 frame equal 1 grain, like it is in that case. And this is also good. And this is especially true with audio because there is people that want really, really low latency, like 1 sample. And there's other application where they're fine with a second of audio. So they can configure the grain to whatever suits the need of their application.
It is all definable in the SDK. There's no fixed value for that. In video, it's relatively safe to assume that most application will stick with the frame of video, unless you need really, really low latency. The other thing that it tells me, this is the head index. So it's basically at the moment I executed the command, what was the grain number at the head of the buffer, because it's a circular buffer of 2 frames. They're being overwritten constantly, and it tells you that right now the head of the stream is that index. That's the further the more in the more close to the real time that you can be is this thing. And the latency in grain, this is a bit fiddly as a measurement because I'm running a Docker exec command. So by the time I execute the command, maybe another grain has been written, and then I'm having 1 grain of latency. But if I execute this constantly, sometime I'll have 0, sometime I'll have 1, and sometime I also we can see 2 grains of latency. It's hard to get more than 2 right now because I only have 2 grain in my buffer. So I would be very, very surprised to see any number higher than 2 in this specific example. Oh, 3. That's a good question to ask to some of the developers, but and this GStreamer application is not really optimized yet as well. So the last thing that we will confirm is we will just go check directly into the volume in the flow in the grain folder. The MXL info tells me that I have 2 grains, so let's just go check. What do we have? We indeed have a data.0 and a data.1. These are my 2 grains. And that's, we'll see later on other exercise, we'll have more grain than that in the buffer. It depends on what we do. And one thing that I didn't mention is we didn't see the .json yet. I skipped it. Sorry. Let's go check the .json file because that's basically the definition of the grain. For those familiar to 2110, it could be seen as something similar to an SDP file. And we have some key things in this files. There are tags, format, how do they call that? A format, I don't recall the name. But this media type is very important because when we write media into memory, we need to have this, all the application need to have the same language. So they need to pack the data into the memory the same, because if they don't, they just won't be able to read each other content. Right now, as we speak in the SDK, the packing method for video data is v210 and 10-bit, so it's 422 10-bit. It's a packing method that is quite old, coming from QuickTime, if I remember correctly. And for audio, it's float 32. That's how they do pack data. And why I'm showing you this, the rest is mostly like this is 2997. It's progressive. You have the resolution for Y, CBCR, color space, the usual stuff that we're used to see. But this V210 stuff is interesting because these grains are raw data in V210. And in this, in step 15, we can use FFmpeg to read raw data in V210. This command is a bit complex. I'll just briefly explain what it does. DD is a way to read a file, a raw file, but we use this because we need to skip the first 8 kilobit of the grain. In the grain structure, there's not only media, but the first 8 kilobit of the grain is metadata for the grain. And they left quite a FT padding there for future use. If your application would need media data to be transported within video grains, you have the ability to do so. But if we want to use FFmpeg to read it, we need to start to read it after the first 8 kilobit. And that's what this DD command does. And it passes it to an ephemeral container. We'll run it once, and it will run an FFmpeg command to read that grain. So let's just try this and see what happens. And the FFmpeg will output a PNG in my repository. So we'll see if it does work. FFmpeg is working. If you're executing this command and you didn't do it yet, you will see that the container needs to be downloaded first, but at some point it will execute. And if I just do ls, I now have an out.png that I will go just on my hard drive and fetch it to see what it is looking like. For Windows user, your WSL folder structure is available directly in File Explorer. You can see there will be kind of an extra drive, which is called WSL, Ubuntu, or Alma, whatever you call your VM, and you'll be able to navigate to your repository, MXL hands-on. It's in Docker, exercise 1. I have my output PNG, and this is what is being written right now. That's one of the grain of the color bar, and we'll be able to see it live in other example later on.
If you can access WSL share on the Windows computer, which I found I couldn't for some reason on my own, you can push it out from within the WSL environment and under /mount MNT. There's a C drive of the host machine.
Of those machine, yeah, okay.
You push it out from within the computer as well.
And you didn't find it on your
For whatever reason on my own computer,
okay,
that WSL share is not accessible.
Weird, because mine on my PC at home, it's mounted directly with all the other file, and I don't recall having done something specifically for that. I'll check that, and I'll try to put an extra step maybe in the repo to explain how you could access your data if you're not finding it. Yes.
So if I'm calling a color bar in MXL,
yes,
all these 15 steps has to be created.
Well, we show you the under the hood right now. We
That's
expect that your friendly broadcast manufacturer will hide
all of this.
99.999%.
But to answer your question,
That's why they are in business.
if we go back to this exercise, the color bar was up after Docker Compose. As soon as you start the container, the color bar was being written into memory. All of these extra steps was to look at folder and check what are the file structure is looking like. But and basically the two other command was to change the directory and to look at the Docker Compose file. So basically, you just start your container, and if your media application is ready to provide media, it will provide media directly into the.
This is still much faster than calling applied, sending get a code, send the PO, color bar generator. Nothing against applied, but they were in the room, so it
And the last two steps is just to cleanly do Docker Compose down. So we'll shut down these two containers. And when doing so, we'll just look at the volume that we have on our machine. And it's empty now. /domain is empty. The flow are gone. They're not retained into memory. They're just gone. And they would reappear as soon as I would restart the container. So that's a bit of the file structure, how it works. It's basically a very simple SDK that leverage Linux file structure to exchange media through shared memory locally. There will be more complex infrastructure or instruction to do exchange in between hosts when it's going to be available, but they are still working on it, so it's not yet available. So if we go check the exercise 2, we will just try to understand a bit what's the concept of domain. So in this exercise, it's very similar to the other. It's just that we have two writers and one Docker that will container that will read. Initially, the two writer is writing into the same domain. We'll check that we have two flow now in the domain because we have two writer. They're writing two flow. And at some point in the exercise, we will just tell one of the container to write flow into another domain. And we'll see that it can be used as an area of segregation in your environment if you want to, let's say, isolate playout from production or whatever would be your security risk mitigation, you don't want certain application to have access to certain flow, you're able to separate this using domain. So first step is quite simple. We just need to change folder. So we will go to exercise 2 folder. We'll look at the Docker again, the YAML file or Docker Compose. So we still have one writer, same config as before. I'll skip the second writer, but I'll go to the reader, same config as before. You also notice that on your container, you could configure the mapping of the domain as read-only. I know that this is a reader. I don't want it to pollute anything into my media functions. So I don't want it to be able to interact with the flow. He's only supposed to read. He's not supposed to write. That's possible. Now the second function is a bit more advanced than this one because we're also mapping a single file. And when we start the container, we run a specific command. And why we're doing that, it's because natively the GStreamer test generator that writes into MXL has one unique ID and it's hard-coded in it. If we were to use twice the same, we would write the flow in the same folder with the same unique ID, which would be similar to trying to send a multicast flow twice on the same multicast IP address, which would not be good. So in order to do that, we are providing it a .json. In this case, it's not hidden because we have put a name in front of it. And the .json is, it's just a copy paste, mostly a copy paste of it with a different description and a different unique ID in it. And we tell the MXL GStreamer video test source to use a specific JSON instead of using the one that is coming with it. And this T command will speak about a bit later, but it's basically in the color bar, there was some ident burn-in. You can control the ident burn-in with this piece of text.
Too, that's creating 2 separate ring buffers in the same domain, right?
Yes, that's what we will. That's the purpose of this Docker. That's why we start 2 Docker writer. They both write into the same domain. So let's start these and let's
You have 2 color bar generator for the price of up now.
So once the image are downloaded, it's really fast to start. These containers are started. I just take an habit of looking that they are started correctly. Yes, they are. And let's look at the domain now. So same command as before. We just look at the file structure of the domain. And now I have this, I recognize this unique ID because I've worked with it quite a bit. This is the built-in unique ID of the GStreamer test generator. And this is the new unique ID for the new flow. If I just go confirm this by looking at my drive, I now have 2 folders. There's 2 streams. There's 2 flow into separate ring buffers. Let's put this new ID into memory as well, because it's going to be easier to check. It's just creating a local variable with this unique ID in. This is, I've showed you directly with the graphical interface, but we can look at the actual volumes in command line, which is the two flows are there, and it's with colored. In my terminal, it's colored, so it's a folder with file in it. Similar to what we did earlier on, we did MXL info on a specific flow by specifying a unique ID of the flow. We can use MXL info to
look at a domain, a specific domain, and he will list us all the flow that is available in this domain. So if I just do that, and this is run again, Docker exec, we run the command from this container, which is the reader container, and we are looking at the d/domain and /l for listing the flow. And we do have two flow. And now that's what's nice is they have also included the description of the flow that is contained in the .json. Before that, or in the earlier stage of this application, it was just spitting unique ID, and you had absolutely no clue about what those flow were. You would be hard pressed to guess when you have 100 of those into a domain. But now you have the descriptor that is contained into the .json, and you have the name of the functions that have created it that is also described in the .json. Yes.
So there you have frame size, frame rate. Is the MXL layer handling any conversion, scaling? So in this example, both of those generators are the same format, same
Yes.
frame rate.
Yes.
So if they were two different frame rates, you would need an application to receive it, convert it, translate
Yes,
it.
absolutely.
So the media exchange layer does not handle any resizing or frame rate correction
No.
whatsoever.
No manipulation. It's really similar to a very high-speed network for 2110. You can pass 4K, 1080p 60, 1080p 50 on it. It's agnostic of whatever you pass it. The same is true for the media exchange. You can put whatever media format in it. You could even put square video if you want. There's no regulation about that. But of course, you need an application that is able to understand that and do something with it.
And I believe that for me, that's a feature of not doing it. Because it did enable quick adoption from the vendor and interesting participation. But now imagine you go tell DRAS, you know what, the media exchange layer is going to handle standards conversion. They make a business out of that. So with that feature set, the MXL doesn't compete with their core business. It's not good extra player.
Yeah.
You let the media application do what they're good at. But to be honest, in the initial discussion between the vendor, some vendor were proposing that the MXL should do basic adaptation. But
If I go quick, 10 minutes, yes. If
Oh,
I
sorry.
go faster, if I take time to explain, it might be a bit longer, but yes, two questions.
I have two questions. One is, are these containers always take the first grain or head? If I understood correctly, you could also read a previous grain to sync up for
Yeah.
another source.
The way the basic, first of all, the reader container right now in this drawing, he doesn't read anything. It's just there to look at the domain and run MXL info, which is not a media application. It's a tool that gives you information about a specific flow. We have a GStreamer sync that will consume the grain and consume the video. But for that in command line, you don't have any graphical interface to show it. So it's pointless to run this. In the third example, we will run another container that has a graphical interface on it that we can log into with the VNC, and we will be able to see those grain. By default, the GStreamer sync application will always read the head of the grain train, if you wish, or the buffer. So it will always try to go to the latest grain.
Okay. The second question is, can you comment on the latency of this technology compared to existing NDI and SRT?
I don't have firm number yet because we don't have any tool to measure it correctly, and except the MXL info, which is a bit kind of random based on grain.
But as soon as we have audio available, I'm expecting that we will be able to measure latency quite more precisely. And I expect it to be way, 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 way faster than NDI. I would be, if the application are well optimized and well written, it should be basically almost instantaneous. We should inside the memory. Of course, if you need to go out and interface or somewhere else, it might take a bit of time, but inside the MXL realm, it should be almost instant.
Thank you.
No other question?
Nope.
So yeah, I've started these container. I've checked the MXL info. It told me that I have two grain. Now I'm gonna do Docker compose down already because what I want to do a small change. So what I'm doing is we do have in another folder another Docker compose file that is slightly different. And the only difference in this Docker compose file that we will use right now instead of the first one is that the second writer is binding a volume that's called domain 2. It doesn't exist yet, but as soon as the container will start, it's going to be created. And it's a new, basically, MXL domain. And we'll see what does that do exactly. So in order to do that, I'm just going to copy this new Docker compose over the one that I have here. And let's do Docker compose up again. I will skip these command line because I will show you graphically. Now we have two domains. Inside the first domain, we have the original flow that starts with F5BE. This is the container that we didn't change. And in the second domain, we have the other flow. That's the second container that we just changed the command to points towards a new domain. And basically right now, my application either reads from domain 1 or domain 2. It can be mapped on both. You could have the application that reads on multiple domains, but it allows you to make segregation in your infrastructure if you want to separate critical stuff. And since it's already late, I'll just do a Docker compose down and we'll just go to the last exercise, which is the most interesting. Back to main page, exercise 3. So in this exercise, we are using all the tools available right now in the MXL SDK. So we have the GStreamer writer, which just write the color bars. We have a GStreamer clip player, which takes a transport stream file, a TS files, and loop it and play it. It plays the video. And we do have an MXL info application that will run on this container that we're not using. I just left it into the Docker compose file. But we will use a Docker image that has a FXCE desktop installed with no VNC. We'll use a web browser to go inside this container with a web interface, and we will use the GStreamer video sync tool that is able to consume a video flow and show it on the screen. That's basically what we will do right now. So let's just change folder. Let's just quickly look at there's a bunch of stuff, but the addition now is this guy. which is basically a aceto. We took an image that is widely used that runs Ubuntu 24.04 with XFCE a desktop environment. It has a built-in VNC viewer that you could access through a web browser. And the only thing we do with it is we're mapping it into the domain. So by its own, this container doesn't do any MXL stuff. We will, after it's deployed, log into it and we'll install it with a shell script that we build that will install all the GStreamer dependencies and the GStreamer video sync app. So let's start these containers. On my machine, they have been downloaded earlier on, so it was quick. But these two extra container, the one that writes the clip player, also I didn't say it, but we also are using one container that is using the clip player application, which is a bit larger because it needs a clip file and other stuff. But once they're up, we can basically just go into a VNC window. It is written in the documentation that the password is headless. And we have a desktop command, but before doing, no, not this guy, I don't need my, I've lost my Git. Go back to this exercise tree, Docker exercise tree. No, sorry about that. Exercise tree.md. And we'll just copy paste these commands, cd root sudo.install. It's this a small shell script that in the Docker compose file, it's already mapped to the container. We will run a shell script. Basically, it go fetch all the files for the GStreamer application that is already compiled in the repo, and it's installing the GStreamer dependency that it needs to run because it's a GStreamer based application. So, and for those not familiar to know VNC, you have a small pane here where you can do copy paste stuff. When it's there, you can then paste it into a regular terminal. Paste. Yes, it could be dangerous, I know. And depending on your connection speed, this could take a bit of time because GStreamer somehow is not a small application for something that is online only. I'm gonna go.
Clip layer function. If you're seeing errors about video skip frame deck.
Yep.
What is slow or what's behind it?
Basically, right now the GStreamer video stream sync app, the ones that reads, is a bit. It's in fact not optimized at all. It's only has been built for demonstration. The full GStreamer plugin is being worked on, and I do expect these errors to go away at some point. But what it means is this reader is not able to keep up. It's skipping grain, or in this case, frame. That's what we will see. And depending on the machine you're running it might not do it. It might do it. On my PC at home, which is more powerful than my Mac, it's not doing it. On my Mac, sometimes it's doing it, sometimes it's not. We'll see. So GStreamer and the MXL GStreamer video sync has been installed. I'm gonna go back, take my next command, which is just from this I can type. I don't need. So inside there, I could do ls/domain
And we see that we have 2 flow. And the nice thing with the GStreamer clip player, depending on the clip that you give it, it will detect the format and it will create the JSON out of it. It will give it a unique ID on its own. So you don't have anything to do with this this test tool. You just give it a transport stream file. You say, play this, and it will set up all the required information for it to work. And what I'm doing here is I'm gonna copy the flow ID of the first stream, which is the color bar. I'm gonna start the GStreamer video sync, pointing to the domain -v because it's a video flow. At some point, it's gonna be something like -a for audio flow. Why there's a difference? Because there's a slightly difference in how they structure grain information for audio and video, but it is not fully released yet, so we cannot test it for now. But at some point, I expect that we will be able to do -a and give it an audio unique ID. I need to copy this here first. And then I can paste it here. Very dangerous stuff. And I have a color bar. Playing, that is playing directly from my memory. Just a word of advice, if you're regularly doing this on your WSL instance on your PC, make sure that you are really mounted in TempFS for your /domain, because that's a very good way to kill an SSD. You're reading and writing file at 30 frames per second. It's not very good for the write cycle of the disk. And normally the exercise I have the same error here on my, no, let's see. Normally the exercise ends there, but I just want to show you, if you follow all of this at the end, there's a question like, how can we go check the other flow now? Because we saw that in the domain, there's 2 flow. Let's just go into this machine and see if we can do that ourselves. So if I do ls/domain, I have this. I know for a fact that this one is the color bar because 5FBEC, I've saw it many times and I know it's the app. So this one must be the clip player. So I'm just gonna do flow2_it equal to whatever I have there in my buffer, paste selection. Oh, yeah, flow2, not flow. A commercial, it's not gonna work. Okay, that's good. And the command that we did for running, this is just a comment that I will delete. This was the command to run the flow. So let's just go check what flow2 looks like. And it's CBC Sizzle that is playing in loop and writing into memory. And if we look correctly, we will see that it is not 100% fluid. I'm pretty sure that if I kill this window or if I move this window, yes, I do have misgrain. That's it for this hands-on demonstration. This repo will keep growing as new tools are developed, and as we explore this at CBC, we will share how we see our vision of a DMF world. We will explore ways of
spinning up those apps, connecting them together, and explore all the available functionality that MXL can offer, including inter-host exchange when it's going to be available. Any questions?
Any questions?
Yes, Lord.
How could this work, or could this work across geographically dispersed applications, like from one site to another, or in the
I
cloud?
don't think MXL is the answer for that. You could definitely work in the same cloud region because there are provider for libfabric like Amazon Elastic Fabric Adapter that is leveraging RDMA in the cloud in between host instances, but it's not going to be useful if you're crossing the ocean with all the latency on the network. I think that you'd be better suited with like super low latency WebRTC connection or stuff like that to do this in video.
Okay, any other questions? No?
All right, quickly, there's definitely a CBC theme you'll notice in our upcoming meetings. CBC very generous in doing some more presentations. But on November 12th, we have Julie Kerr, who's Executive Director of Revenue Strategy and Foresight for CBC Radio Canada, on multi-platform content delivery, fragmentation of audiences and revenue streams. So really looking forward to that, really thankful to have Julie for that. And then on December 9th, a meeting on HDR. So Pierre Hu, on HDR and exploring sort of UHD 4K versus 1080p in an HDR application. Two more upcoming presentations featuring CBC. And then wanted to let everyone know our SMPTE Toronto bootcamp in 2026. So we've already started working on that. So we have a date set, which is May 21st. We're working on all sorts of details, venues, themes. It is going to be focused on sports. So tech innovations in sports media is our working title at this point. And really looking forward to, we'll keep you all updated on that, but it should be an excellent event. All right. And Tony, do you want to speak to this or?
So in November, which is next month, the 5th and 6th, we're going to be at Pro Fusion, which is across the road, the convention center. 1 year's free membership. The form, there's a bunch of goodies that we're going to also putting on giveaway package, so we're going to do that for that. And yeah, we'll do some buttons.
Right, excellent. Thanks, Jordan. Okay, and again, tonight, anyone interested? Grace O'Malley's 14 Duncan Street, which is 2 blocks north of here. Anybody feels like socializing and a drink, come on by. And that's a wrap.